Hi guys, welcome to learning microcontrollers. Today I am going to teach you how we can interface a water level sensor with a PIC microcontroller. So let's start. What we are going to do here is that we will be having our PIC, a water level sensor. Water level sensor has 3 pins. One is signal, another one is the positive, and another one is the negative. We need a 5 volt power, a basic power which we give to PIC. Even a PIC kit will do, a common ground which all the PICs have. The signal pin is our ADC pin, which will go to the pin any channel. I had selected the A0 channel of the PIC, that is pin number 2, and power will go to the power, ground will go to the ground, and then I will use a CH3418 TTL2 USB device, which I had showed you how to use in my previous videos. This device will send the data using a UART port. It will fetch the data from the PIC and will send the data to the computer. And we connect the TX of the UART device to the RX and RX to the TX. And that's a basic simple connection. Now let's start. First we open our PIC IED, MikroC, go to the new project, select the standard project, click next, any name like learning microcontrollers / water level. That will do. And I am having a PIC16F877A and crystal is 16. Click next, finish. Alright, here we go. Alright, the IED has opened. Here our coding begins. So let's start with our coding. Alright, the first thing is first. As I told you, we are using our ADC pin. So PIC will need an ADC library. Click the ADC one. First we need to initialize the ADC using this command. This is ADC initialize. You can see it in the library. Sorry, the ID crashed. I restarted ID. Okay, here is our command. We copy it. ADC initialize. You simply need this command. ADC initialize. It will initialize the ADC module. Give it some safety delay like MS of 250 will be enough. The next thing is, as I told you, we will be using a UART device as well. So for that, we initialize the UART as well. First, select the UART library. Write UART. Here is our UART library. We first initialize the UART. So there we have our UART initialized. Double click on it. It will open the UART library that we needed. Alright. Here we go. The UART library. Paste it as well. So our UART pin is also initialized. Give it a safety delay. Like 250 will be good. Here we go. Now since these both the buses are initialized. One is the ADC device, ADC converter, and another one is the UART bus. Now we go for the forever loop. While one, we start from here. What we are doing is that we are going to read an ADC value. To store an ADC value, we need an integer. Integer, write like LVL, water level value. It will be fine. This variable will store the ADC read value. Alright, let me show you how we read the ADC. Alright, here you have ADC read this. You need this. Copy it. That is our ADC read. It will read the ADC. Give the variable you are using here. They must be the same. This variable will be storing the ADC read value. This is a channel. Since as I told you in the presentation, we are using the A0 pin. A0 means channel number 0. We are taking value from 0 channel. We will connect the sensor to 0 channel. Alright, let's save it. Alright, it's saved. Alright, give it some delay so it takes reading after some time, and we don't make or we are not willing to make it like a machine gun. So give it some delay like 70 will do, will be fine. Alright, better thing is we give it more delay like 100 will be good. What's wrong with it? All right, here we go. Now the next thing is we need to do some conversion. Since we can't send this value directly to the UART device, to the UART we can only send, you can see what we call as strings. So first we need to convert the int to string. So there it is, int to string. We need this command, right, double click on it. Here it is, int to string. You copy this, you paste this simply here. And now this first digit is the one which is to be converted, which is this. And second one is the one in what it is to be converted. Give it another char WLVL1, like we will send a value of like 4 digits. For that 3, 0, 1, 2, 3 are like 4 digits. That will be wonderful. So we have this as our converted value, place it here, and this as our value which we will convert. To place it here. So it will be converted to this. Give it a little bit of delay. Delay ms like 50 will do, 60 will do, that is fine. Alright, now the next thing is we need to send it through the UART channel. Again open the UART library. UART, since we are sending 4 digits, it will be a text. UART write only sends a char, one char. Alright, so UART write text, here it is. No, it's not. Here it is. You copy it, paste it here. UART write text, what it should send? It should send this. So place it here. Alright, it will be fine. Now the next thing is, we can't send UART, it will be unstable code. We first need to give it, like first we need to check either the TX register is ideal or not. For that purpose, you give this loop. UART TX idle, when it is equal to 1, only then send the value. If it's not equal to 1, just leave the loop. It will repeat the loop, and in that case our code will not hang. It may take a little like a time which we cannot see with human eye. The wasted time will be this much small, so that will be fine. Just send values after 100 ms of interval. Alright, it will be fine. Alright, our coding is complete. Check the loops. While loop, first bring it up. So alright, this is our void main loop missing, so we need another bracket right here. It will be fine. Now the last one must be this loop. Yes, it is. While must be the second last. It is. And another one is this. Alright, it is. This is wonderful. The coding is complete. Now we simply come to the hardware. Alright, here is our hardware waiting. Alright, here is our hardware. This is the water level sensor which I had just shown in the presentation. Alright, what we do, we have, you can easily see it has 3 pins. As I told you, it only has 3 pins: signal, positive, negative. So signal will go to like pin 0 is like pin number 1, pin number 2 here. Other one is a positive. Positive will go to the positive. And another one is a ground. Ground will go to the ground. This completes our for this device. Another one device we were going to use is UART to TTL. As I told you, it's a very common and easily available device. Has 5 volt VCC, TX, RX, and ground. We only need TX, RX, ground, and 5 volt. Alright, let's connect them. TX will go to the RX. TX is pin number blue. TX is the blue one, and gray one is the RX. Right, 21, 22, 23, 24, 25, 26 is the TX, and 25 will go to the TX pin because it's RX. TX of the device will go to the RX of the PIC, and RX of the PIC will go TX of the device. So now this is our power, and this is the ground. Do not connect the power until you had not burned the code. So to avoid giving power from 2 devices. For the burning code, we need the PIC kit. Here is our PIC kit device. I connect it. Now let's open the PIC kit driver to burn the code. Here you go, our PIC driver is open. Now we simply need to first detect the device first. Tools, check communications. Wait, let it detect the device. Detecting PIC. Alright, found the PIC. It found the device. Alright, now we simply need to import our code. Click on File, Import, select the file where it is. LM water level, here it is. Open it and click on Write. If everything is fine, it will write the code. Oh, sorry, I forgot to select the PIC. Alright, this is my mistake. We need to select the PIC. I forgot to select the PIC. Let me select the PIC. Alright, we are having PIC16F877A. Here it is. Again, import the file. Here it is. Water level, click on Write. Alright, it is burning the code. Let it burn. This PIC has a huge memory, like 16K of memory, so it takes a more time. While many other PICs have less memory, so they get burned easily with this small code. So here we go, the code is burned. Now we simply give power to the PIC. So we can get power from two sources, either the PIC or the USB to TTL device. So I will get power from the TTL device. I remove the PIC kit. I only connect the TTL device. Alright, TTL device is on. You can see already I have not connected the diode, so it is taking the reverse power. That is not a problem. Alright, let's connect the device. Here we go. I had powered up the PIC. Now go to the tools. Open tools. Here you have UART terminal. Click on it and connect to the device. Alright. I think we have the TTL2 device connected to COM4. Here we go. Here we are getting the readings. Since our water level sensor is like not in water, so we are getting 0 reading. You can see that it's not in water. Let me get a glass of water. Here we go. We got a glass of water. Now let's see what happens when I place the sensor in the water. Here we go. Alright, the power has been disconnected. I accidentally alright, I replaced the wire with a new one. Alright, let's see what happens. Now clear the screen first. Alright, it's not in water. We are getting values like 0, 0, 0, 0, 0. Let me submerge. Alright, it's a little bit in water. We are getting some readings, like you can see. We are getting some readings. Again, little bit in water. See, we are getting readings. Now I dip it more. See, the readings start to increase. I dip it to the max I can. So at the most highest value, it's like 625. The maximum value we got was 625. And now let's see, let it dry up. Alright, when it's at like C0, minimum value starts from like 400, and we are also getting values like 396. It's the minimum values. 396 is a minimum. 396 is the minimum. Now let me dip it half. At half we receive values like 471. Alright, and the maximum is like, again you can see they are like 533. You can see that. Alright, now let's make it some useful stuff, like let's do some stuff with it. All right, what we are going to do right now is that we will take like 4 LEDs and we will dip it into the glass. When it dips like little bit, 1 LED will glow, 2 LEDs, and similarly when it will dip completely, all the LEDs will glow. All right, so we take 4 jumper wires and also select 4 LEDs which we will be using. All right, here we go, 1 2 3. Let me get one more jumper wire. All right guys, here you go. I had connected the wires, 4 LEDs. There are the 4 LEDs. 1 2, leave these 2, 4 5. These will be used. All right, so let's do the coding, changes in the coding that we will be needing. We will be needing to do this task. Let's do that. Okay, let's start the coding again. All right, what is the scenario that you always start giving conditions after the ADC value? Conversion is done later. It's stored in this variable. Always start from here. All right, so if WLVL is double equal to like is greater than equal to, you can say like 390, the minimum value we received was like 390, or we say that is greater than equal to 380 and is less than, WLVL is less than equal to like 450. All right, 450. All right, if it's greater, it will remain open. That's fine. So it's fine. Then what is do? Port B.B7 equals to 1. Blink the LED of port B.B7, delay MS, like keep it on for 80 milliseconds, and then don't turn it off, keep it on. Then turn it off, that will be fine. 0. All right, that will be fine. And next, else if WLVL is greater than equal to 380, and then it was 400, like the values we get was is greater than equal to 450. Then what I do is, I'm just giving a rough estimate. You can program it better if you are making a project regarding it. This is called stepping. I'm giving some steps to it. Turn it on, keep it on for like 50 ms, and then turn it off. P.B7 equals to 0. It's done. All right. Now, else if the value increases 500, then what it must do? Just copy paste it. Copy paste the whole loop. Do the easy task. If you can do it easy way, then why should go we should go for the hard one. Oh, sorry, I clicked the function accidentally. What the function? Wait, where was I? Here it is. All right, if it is greater than 500, then blink. All right, let's check the coding first. Port B.B7 if greater than 380, B7 and the B6. What are we doing? We have 4 LEDs. B6 must also turn on. And the last step, and B6 must also turn off as well. So it will be B6. Turn on and turn off both the LEDs. And in the last one, all 4 must turn on, like we give it port B simply. Port B must be equal to 0 into FF. 0 into FF means all pins will be getting a 0, or like 1, 1, 1, 1. And 0 into 0, 0, all will turn off if it increases 500. So I had given it 3 steps. All right, that will be fine. That seems to be wonderful. And if none of these condition is reached, you have to give an else as well. if, else if, else, and else none of these conditions are received, what it must do? It must turn the whole port down, like no LED will blink. So that's fine. Now let's check our coding, what happens. Alright, let me disconnect the power from this device. Alright, Uart device is disconnected. To keep it safe, we connect the picket. We get back to our, like you can say, code. We click the right button, but let me first check, is it correctly saved? Let me recheck the loopings. Alright, I don't want to come back here. Alright, it's fine. First loop is fine, second loop is fine, else if it's fine, everything is fine. Now let's burn it. Click on right. Let it burn. So guys, we did made a terrible mistake in our codings. Let me show you what we did. Let me tell you, let's comment this. We left the coding here, and it's not possible for us to continue with it. Since we gave this condition, so only this loop kept on executing. The other loops will not execute. So I made some corrections. Alright, and I also forgot to initialize the trace register, which I just did right now. Alright, now our code is ready. Let's see, take a look. Let me tell you what I did previously. I didn't wrote it down, but I was about to write it down. Then I said, nah, leave it, it will take time, but it was needed. So here I give the condition. We use the double AND operator. It is a comparator. Only those PICs which have built-in comparators can do this task. And nearly every PIC, PIC16F877A, PIC16F887, all have that. So you simply need this. It requires two brackets, one to close the main bracket, this one, where it is closing mate. One is this, and this one is wrong. So always check the brackets. And MikroC do have good bracket checking. Alright, here we go. It's good. Alright, now what will happen is that it will blink the first LED if the values received are in between 380 to 450. Now it will blink the two LEDs B7 and B6 if the value received is in between 450 and 500. And similarly, it will blink the, you simply have to copy paste that. Third LED if the value is like all the LEDs if the value is in between 500 to 550. Now let's burn this code. Click on right button. Read, is it working correctly? Alright. Let me first check, yes, it's working. Let me write the code and come back to you. Alright, the code is written successfully. Now let's come to the hardware. Here is our hardware, that is our glass. Let's open the USRT terminal and connect the TTL to USB device. Disconnect the PIC kit, we give power from the TTL to USB device. Right, here it is connected. We power up the device. Here we go. Clear it, and I think the COM is 4. Select the COM. The device is not detected. Let me do it again. Alright, here we go, our device. It's connected. Here you can see we are getting our readings. Since no reading is above, you can say, bring it down. No reading we are getting is above like our LEDs. Now you can see all the stuff. Alright. You can see that no reading is above like 500. You can see that it's 172 we are getting here. Alright, now let's submerge our sensor. Here's our sensor. Let me submerge. See, the readings we received are above 500. So LEDs have started to blink. Let me dip it further. So our coding is working fine. And so guys, I again checked the code. We did made a mistake when I copy pasted. Oh, let me show you what mistake we did made. I showed you my mistakes intentionally so you can correct them as well. All right. I copy pasted this and it was the same like I gave both the values the same, so I corrected it this to this. All right, so this is our main code. Let's check it. Disconnect this picket, connect power from. All right, you must be able to see everything, the whole movie, the LEDs, the glass, and the controller as well. All right, here we go. Let's get started. Open the tools, UART terminal, select COM4, connect. Now power up the PIC, so readings start coming. All right, the device is powered up, so we are getting our readings. All right, it's like this, no LED blinking. Let me put it in water. See, the LEDs started to blink. You can see that it's below 443. When I put it out, values drop, and when it will dry up, all the LEDs will stop blinking. Just wait for it, all the water drops. See, only one left, and it will also turn off. So let me dip it in again. You can see all started to blink. Now it will start drying up, see, and finally all the LEDs will turn off once it dries up. So this is a basic demonstration how we can use a water level sensor. You will have the code in the bottom, and you know I corrected this code so many times. The one you will get in the bottom of the description is 100% working code. Guys, so I believe you learned from my video. Any improvements that I can make, I will love to have your comments. So I will be very grateful if you give me a comment and tell me what's wrong. So I will try to help you in the best possible way. So guys, let's give it a last try. Now it dried up, all LEDs off. Again, put it in. See, the values increased. Now let's take it out. See, the values are dropping. See, 2 left and 1 left, and when it dries up completely, all right, it's drying up. So this is the demonstration, guys. I believe you liked the video. So have a nice day. Bye.